Right. Good morning, children. Welcome back to ICAN Physics Academy. Now, in this class, we are going to solve 8.5 and 8.6 from 8th lesson Cbse exercise problems. Let's enjoy the class. A radio can tune into any station in the 7.5 megahertz. Okay. So frequency is 7.5 megahertz. Convert the megahertz into hertz. So 7.5 into 10 to the power 6 hertz to 12 megahertz. So the another frequency is 12 megahertz. So now convert the frequency, megahertz into hertz. So 12 into 10 to the power 6 hertz. Okay. So what is the corresponding wavelength? So C equal to mu lambda. So lambda equal to C by mu. Okay. So this is the general formula to calculate the range. Okay. So wavelength equal to C. So what is the value of C? Velocity of light 3 into 10 to the power 8 divided by mu. What is the value of mu? 7.5 into 10 to the power 6. The plus 6 goes to the numerator as minus 6. So that it becomes lambda equal to 3 into 10 to the power 8 minus 6 divided by 7.5. So in the denominator we are having one decimal point, so that it is multiplied and divided by 10. Okay. So 3 into 8 minus 6, 2 into 10. 7.5 into 10, 75. Okay. So we can write 10 to the power 2. So 100. Here on 0. Okay. Divided by 75. So when we multiply and divide, finally we can get 40 meter is the wavelength. Okay. Now we can go to the second part. It's 12 megahertz. So the wavelength lambda equal to C. So what is the value of C? 3 into 10 to the power 8. Now, what is the frequency? 12. So 12 into 10 to the power 6. So the plus 6 goes to the numerator as minus 6. So 3 into 10 to the power 8 minus 6 divided by 12. Okay. So the wavelength lambda equal to 3 into 10 to the power 8 minus 6, 2 divided by 12. So 3 into 100 by 12. So 1 3 is 3, 4 3s are 12, 1 4 is 4, 2 4s are 8, remainder 2, 5 4s are 20. So 25 meter. Okay. So what is the range? What is the range? That is 40 meter to 25 meter is the range of wavelength for the given frequency. Okay. Do you get it now? Do you have any doubts? No doubts. Okay. Now, a charged particle oscillates about its mean position. Okay. So let us consider this may be the charged particle. It is oscillating about its mean position. So it's for one oscillation. What is the frequency of the electromagnetic wave produced by the oscillator, which gives a frequency of 10 to the power 9 hertz? Okay. So the charged particles frequency is 10 to the power 9 hertz about its mean position. So when the charge is in equilibrium, the frequency of the electromagnetic wave, is also 10 to the power 9 hertz. So it also will be same. Okay. Do you get it now? Do you have any doubts? No doubts.